I'm Mariana. My topic is integrated BIM tools for digital building permit. The thesis was based in Milano, Politecnica di Milano, with partnership from Hofer Italia, the company. So these are some steps that we follow in the digitalization, and then also we are going to follow now in the presentation. First, understanding the needs, then some regulations, definitions, some methods preparation, creating prototypes, and testing. So first, understanding the needs. Sebastian already explained for you already. So a building permit is this document that will gives permission for construction under some specific laws. And it is important because it guarantees a sustainable and controllable environment, built environment. So, I mean, I'm gonna go quick here because Sebastian also explained that, but we have like the traditional methods that it's like we usually have an owner that hires an architect or engineer that we're gonna call the applicant. And then these applicants gonna produce the drawings, usually 2D drawings, paper-based, and then these drawings are going to a municipality. And in this municipality, there is some employer that we are gonna call insurer. And this insurer is gonna like check these drawings according to the regulation that he has, sometimes needing some external consultant. And then if it's approved, it goes to the construction. If it fails, goes back to the applicant, and then we follow the same step again. Bear in mind that this is a very complex process, and it changes a lot depending on the municipality and the legislation. This is just like a summary, a simplification of the process. And then the first digitalization would be like, instead of submitting the paper base, you submit the drawings, but it's still 2D drawings in a platform, like a web platform. And then the rest remains the same, basically. I mean, you do the same checking with the 2D drawings, the same kind of approval. And then we have the BIM-based digital building permit, which the idea is that the applicant will do the BIM model. And from this BIM model, with the data that you have from the model, you run some rule checks on them. Of course, you submit the model in the platform, and then you run some rule checks, some rule sets according to the regulation that you have, and then you have like a report, and the issuer reviews the report, and if it's okay, it's approved. If it fails, it goes back to the applicant. So, I mean, what are the potentialities of the building permit, like the BIM-based building permit? It's because like usually municipalities have a very high volume of projects that they have to run, and then this makes like the process like very long. Sometimes it takes like many days, months to do the permit. So this would increase the efficiency and also like reduce the time for issuing a building permit, and then also reduces the level of subjectivity, because usually when you have an employer that the employer is like checking the model, checking the documents, he's gonna apply some subjectivity of how he understands the rules. If you have already the rules in a computer, they are more transparent, they are direct rules. So you have like a more transparent problem as well. And also the possibility of the applicant to check the models before, as also Sebastian said, and then this is going to reduce the error. So when you submit the models into the application, under the process application, you know that it's already correct. So it's going to also shorten the time needed for the process. Some problems is that since nowadays employers are still using 2D drawings, they don't have a high maturity level, so they don't have like enough knowledge on the field and on data science to do this kind of digitalization. Also, we have a very complex legal frame, like depending on the country, depending on the city, you have like a regulation that is often that also have like a lot of subjectivity. And also there is no like integrated system, so each municipality has its different processes, which make it difficult, because then each municipality is going to need like a different kind of digitalization process. And this makes for like a high investment, like high initial investment that maybe the municipalities alone cannot handle. And also a lack of standardization methods, also, like as Sebastian told, like we don't have nowadays an MVD for rule check or for translating the rules. So this difficulties a little bit the process. But then we have like this process of the digital building permit, like BIM-based digital building permit. And how do we do that? We do that by automated rule checkings. So the rule check, it's a software or a system that you don't change the model. You have the model, but you don't change the model, and then you apply some rules, constraints or conditions, and then you have the result. Then these results gonna be like either pass, fail, warning, or unknown. Summarizing, we have a BIM model, and then you have like some rules. These rules are gonna create these rule sets, and you're gonna compare these rule sets with the BIM model. And then from these, you're gonna have the results. And this process, it's like a standard rule checking process, and it's made in 4 steps. The first step is like the rule interpretation, then you have like the model preparation, and the rule execution, and the result reporting. And these were the steps that guided this research. So each of those steps that we took was related to one of the steps of the rule check. So the idea was creating a prototype that we could understand how the one legislation could be like translated to how the legislation could be translated to a software, and then how you could use this like the computer-based language to use to analyze the models. So first we had to define our regulation, and we chose the British standard for fire safety because it's a standard process independent of the location. So we run from fire the same way in Milano or in Brazil. It's a very straightforward rule. So you have like the distance that you have to the maximum distance that you can travel until you get to a fire exit. And it's also very important, like in the design and development and the conception. So if you need to put like an extra stair, it's going to change a lot your model, your design. So it's important. So you understand that, like in the concept of the product. So from the British standard, it's a very big regulation. So we focus just on the means of escape, which is exactly like how you escape the building in case of a fire. We analyze the regulation, and from the analysis of the regulation, we found out that there are 195 statements. The statements are the rules itself that says like, you cannot travel more than 30 meters and so on. So from this statement, we check all of them, and we classify them according to how easy it is to translate these statements for a computer-based language. So the green ones are the objective rules. They have like clear requirements, so it's easier or more complex, but they are translatable for direct translatable for a computer format. And the second ones, the blue ones are the subjective rules. So they will require some kind of human input. They say like, or some kind of just information about something. So based on that, we find out that basically half of the regulation can be translated, but half of the regulation is still like very subjective. So then we narrow down even more the process, focusing only on the horizontal means of escape, which is the escape routes and the travel distance. And for these, we prepare like these 2 prototypes. First, we prepare like the method, like how we extract the data from this part of the regulation. So we established like a data set for the elements that we need to classify on the models. And we use uniclass tables for classifying those elements. And the idea was to minimize the change of the model. So if you are, for example, an architect that is working a project, you don't need to do anything extra in order to apply for a building permit. You just have to apply the classification system. Then we took like the tables from the tables that are the targets in the regulation, and we translate these tables combining with the uniclass system as well, and we create databases that we will be used on our prototypes. Then we also found like the workflow process, like to understand what are conditions that we need in order to follow the rules of the regulation, and what are the parameters that we are analyzing. So some of conditions is like if the building has sprinklers, if there are fire alarms, how many exits there are. This is going to change like how much the travel distance can be, and this also the risk profile, like the use of the rooms also changes like how much the distances can be and how wide the doors can be and this kind of stuff. So we developed this workflow, and this workflow was applied, was applied creating the prototypes. So we used Solibri model check, and we use also Revit and Dynamo to understand like the difference between the two methods. In both of methods, we run the phases, so the rule translation, the model preparation, the rule check, and the reporting. First, in Solibri, we took some models from Revit, we exported them to IFC, we imported them in Solibri, and then we also imported in Solibri the data sets that we created like in the step before. We use first the sample model of Revit, like importing to Solibri, and then in Solibri we could create like very easily all the classifications that we needed based also on the data sets that we showed before. And we created like the rule checks based on that workflow that I showed, understanding like, so with all the conditionals and which of those databases, which of those information you should check against this model. So we use these templates as rule checks, and then we also create the role. So thinking about like a municipality employer, you just need to open the software, like open the role, and then you have already like the data set, everything set, like to run on this subject. So you only have to import, you only have to open the role and everything is imported. So we had like a good result at the end, but we had some issues. Where is not going? Okay. Especially based on how the software draws the paths. That somehow we cannot control this in the software. The rules are kind of easy to change and to create, but then when you need to change some parameter, it doesn't give you that much customization. So after we created prototypes, we tested on a model that was provided by the company. It's a model of a office building, but we only analyzed like one part that has like a company. It's offices as well. So we run the checks, and some of the rooms was fine, but the software understood the windows as they were modeled as curtain walls, they understood as doors. So some of the paths like both were passing through these windows, which would be wrong, and we could not like change that without hard coding. So it's kind of difficult to control this kind of situation. We try to change the parameters as the software give us, but we still had like the same problems. And when we change how the paths are drawn, like these are created like even more problems. So a review of the software, it's good because many of the rules are already set. So rules, for example, as fire safety, there are standard rules you already have on the software. So it's easy to translate those rules into the software. It's also easy to apply classifications and to extract data from the models because the software is very intuitive. And it also uses IFC, which is great. It might be used like in an initial process of digitalization, when you have like just a few of the rules translated, and it's thinking about like the opportunity. It is good from the issuer point of view, because the municipality could use this software like using IFC models and could, depending on the altering softwares of the applicants. The problems is about the customization of the rules, of the control of the parameters. And also like when it starts to create more complex rules, then it's gonna be like harder to control this on the software. You'll have more problems, so you'll have to check all the time if the rules are correct or not. Then we did like the same rule translation, model preparation, rule checking, and reporting on Ataide software and using a visual programming language. So we use Revit and Dynamo. So the process was in Dynamo was basically that we created like we retrieved the information from the model. We derive the parameters like in order to extract the information needed. Then we run the compliance check using the databases that we have. And then we exported the elements into reports, and we also like put this on the BIM model. So this data is like attached to the model. So these steps were like the scripts that we created for that. And first we had to change a little bit the model. So we have to create some parameters that was like specifically for this. Some parameters like as the travel distance check, like maximal travel distance and risk profile, that like we put the information that we got here, we put this information on these parameters. So these are the scripts that we run, like how we did the scripts. And this is the first results, is how we classify the risk profiles. And this is the result of the scripts that we run and of the database that we extracted from. Then we create like the travel paths. So the travel paths is the escape routes that how the person should escape like from the room until the exit. So this was also created like on the software and on Dynamo, and already like putting the information back on the model, so we could do the run checks, and then we check the model like against the regulation, against the databases that we had, like using also the conditionals that we have. And then you have like these kind of results, like showing like which rooms fail, which rooms pass, and this kind of stuff. And then the last one was like reporting. How do we report there? Like creating schedules in the software, and also like exporting the schedules to Excel. And also we run the same tests on the case study. So these are some of the results that we have from the case study. And like also the same analysis on Revit and Dynamo. we have here a high level customization. We have like an accurate result because you are dealing with the model itself.
1 minute, please.
Oh, okay. And then, but you need like a higher maturity level in order to use this approach. And but it's good because it supports your decision making during the development of the designing process. So it's good for the applicant point of view that you can use this kind of method and in your design process. But it requires like more change in the model, and also it's not great for like interoperability because you have to like run one of the just one of altering software. So some final thoughts that we had like that, but I think the main one is that building permits, it's not a process that it's 100% automated. Some of the subjective rules, they still are gonna need some human input and maybe also some kind of simplification of the legal process. But basically, that's it.